Welcome to the Oracle Retail Merchandising session on replenishment. Oracle Retail supports item replenishment through a number of applications, including merchandising replenishment, advanced inventory planning, which is similar in methodology to merchandising but also provides for time, phase, visibility to inventory, allocation, which allows inventory to be pushed to stores according to a defined inventory plan, and various other manual methods which include merchandising, purchase orders, and transfers. For this lesson, we will focus just on merchandising replenishment functionality. Replenishment is an order for additional goods from a warehouse or vendor in order to replenish depleted stock. Replenishment in merchandising allows retailers to set up automatic ordering for items and can monitor the inventory positions at locations throughout a retail enterprise, down to the item location levels. Depending on the algorithm used, replenishment can be configured to make various recommendations as inventory values change. It can also suggest recommended order quantities, which can manually be added to a purchase order or transfer. Or it can create purchase orders or transfers directly, depending on the level of automation desired. Other key features of merchandising replenishment are forecasted demand from Oracle Retail Demand Forecasting, or RDF, which can be used to utilize more sophisticated methods of replenishing merchandise. Automatic line grouping to generate combined shipments for efficiency, and rounding and constraint scaling to create orders that are tailored to a particular demands of a supplier. Replenishment orders are generated during the nightly batch process. First, we'll look at the parameters that can be set up for the supplier. To manage how replenishment runs for any particular supplier in merchandising, inventory management attributes are used, which can be set at the level of supplier, the supplier department, the supplier location, or the supplier department location. There are several attributes that can be set at this level, which are primarily used to either default to the item location level when activated on replenishment or applied to orders created for the inventory level designated. These include review cycle, or how often the item's inventory level should be reviewed to determine if stock should be ordered, order control, which references to how the order should be created manually or automatically, scaling objectives, such as scaling to multiple vehicles and designating location or order level for their application, supplier minimums, due ordering process parameters, which specify when orders are created for certain kinds of replenishment, pooled orders, or pooled suppliers, which allow orders for smaller suppliers to be pulled together for a single delivery from the pooled supplier, truck splitting constraints for dividing up orders efficiently for deliveries, and rounding attributes. Activity and delivery schedules are used by replenishment to ensure that required inventory is in the right location at the right time. This helps to create more accurate recommended order quantities and deliveries. Activity schedules specify when either the total company or a particular location will be closed. A warehouse location can be closed for receiving and shipping. A store can be closed for receiving, shipping, and sales. Specific dates are specified as close date, such as December 25th. Delivery schedules, on the other hand, specify when locations expect shipments from either a warehouse or a supplier. The delivery schedules do not specify dates, but rather are set up to be ongoing. For example, a delivery schedule for a store might be set to occur every Monday and Wednesday. When replenishment runs and determines upcoming need, it takes these schedules into account depending on which algorithm is used. Store prioritization is used to ensure that stores with the highest priority are replenished first in constrained inventory situations. The concept of which stores are deemed highest priority and the number of groups used is defined for a retailer's specific implementation. The priority group can contain any number of stock holding store and merchandising, including both company and franchise store locations. Store prioritization is only used for warehouse stocked and warehouse cross-linked store stocked categories, as merchandising replenishment outside of contracts assumes unlimited order quantity, which is available from suppliers when orders are generated. Merchandise allows replenishment parameters to be set at a few different levels. We've already covered those set up at supplier level. The next level we'll talk about is item level. At this level, there are just a couple of attributes that are important to replenishment. Those are forecastable, which indicates whether the item will be sent to RDF for forecasting. If not, then only non-forecastable methods of replenishment can be selected for this item. Store order multiple, which can be either eaches, inner pack, or case pack. This determines how rounding rules will be applied to orders for that item. And substitute items, which can be used to specify items that should be used to fill a replenishment order if the primary item is not available. The more detailed parameters for replenishment are set at the item location level, but there are also options to maintain these parameters for a group of locations or even a group of items using location and item list, so maintenance does not need to be done at the granular level. All stock holding stores, including both company and franchise stores and virtual warehouses, excluding internal finishers, are eligible for replenishment. The parameters defined at this level include stock category, order control, and replenishment methods, which we'll talk about more in the next few slides. Supplier and origin country, which designate the primary replenishment supplier and origin country for the item location and can be different from the primary supplier for the item. Review cycle, which defines the scheduled days between examinations of the inventory for reorder opportunities. This is defaulted from the supplier inventory management parameters if defined. Replenishment dates, which define when replenishment should be considered active for the item location. A deactivate date may also be specified if an item needs to have replenishment turned off for a period of time. Presentation stock indicates the minimal amount of stock that needs to be on store shelves and thus the minimum order quantity for all replenishment types. Demo stock indicates the number of items in a location for demo purposes. Demo stock is not included in available inventory and replenishment calculations as it is assumed to be essentially non-sellable for replenishment purposes. Lead times are used to calculate the amount of time between the order is placed and when it arrives at the final destination. Merchandising replenishment tracks this in three ways. Order to pick up, which is the amount of time between when the order is placed and when it is ready to leave the supplier. Pick up to location, which is the time from the supplier to the store or to the warehouse. And warehouse to location, which is used for warehouse-based or cross-dock replenishment methods. Finally, the primary replenishment pack can be used to designate the simple pack that should be ordered in lieu of a regular item. Stock category refers to the method in which merchandise is sourced and delivered. The stock categories available in merchandising are direct to store, in which goods move directly from the supplier to the store via purchase order. Cross-docked, in which merchandise is shipped from the supplier to the store but flows first through a warehouse. Warehouse stocked, which, if selected for a store, would result in a transfer to the warehouse. For warehouses, this is the only stock category option and would be used for replenishment of the warehouse from the supplier. Warehouse cross-linked, which results in a combination of cross-docked and warehouse stocked outputs. For this method, merchandising will first attempt to replenish to the store directly from the warehouse, but if sufficient quantities are not available, it orders from the supplier to the warehouse and then transfers to the store. If the warehouse cannot fulfill the entire request, it will wait for the balance of the quantity of goods to arrive from the supplier. Only when the warehouse has the full quantity to be replenished will it ship the goods to the store. Order control specifies how orders are created based on the recommended order quantities generated by merchandising, and allows a retailer to determine how much automation is built into the replenishment process. The first option is manual. With the manual order control, the system generates its recommended order quantities and writes the result to a database table. No ordering takes place until a purchase order or transfer is manually created by a user based on the recommendations. When the buyer worksheet option is selected, the recommended order quantities are viewable in a buyer worksheet, which is an online screen in merchandising to help create purchase orders using the outputs of replenishment and investment buying. For the semi-automatic option, replenishment generates purchase orders in worksheet status or transfers them in submitted status. The last option is automatic, which creates purchase orders and transfers them in approved status. Replenishment methods are the algorithms that are used to calculate the ROQs and generate replenishment orders. In merchandising, there are 8 types of algorithms, some of which utilize demand forecast and others which do not. The first algorithm is called constant. It is designated to achieve a constant stock level using the pre-established maximal stock level as a reference. So when the stock level drops below the maximum, the next time replenishment runs, it generates a recommended order quantity to bring the stock to maximal level. This method is sometimes referred to as the buy one, get one method and is effective for very slow selling items or items that are typically bought in multiples. Min-max is similar to constant algorithm, but adds another layer of complexity. Instead of aiming for a constant stock level, the min-max algorithm maintains stock levels within a window between minimum and maximal stock levels. Only when stock levels drop below the minimum does replenishment generate a recommended order quantity to bring stock back up to the max. Like constant, this method would be used for slower selling items. The floating point algorithm varies similar to constant, but is more complex as it makes use of historical sales data to calculate the maximal stock value. Time supply is a forecasted-based algorithm, which is based on the number of days of supply held in a store. The key settings for this algorithm include min and max days of supply, which are used to calculate the minimal and maximal stock levels when generating recommended order quantities, and the time ship horizon, which is the number of days over which forecast sales should be averaged. When the system uses its time supply horizon, it is asking how much of the forecast are we going to look at to come up with our new recommended order quantities. This is used to determine a new minimum and maximum. The recommended order quantity for this method is generated when net available inventory reaches the minimal days of supply. The order company is based on a rate of sale based on forecast sales, max days of supply, and presentation stock. There are also 2 variations on the time supply algorithm. The first is time supply issues, which is the same as that for stores but uses transfers out of the warehouse or issues for the forecast. The other is time supply seasonal, which combines the basic time supply algorithm with an end of season stock goal. Another forecasted algorithm authored by merchandising is called dynamic. It is the most complex and powerful algorithm available for merchandising replenishment. This algorithm is based on service levels which specify the percentage of time that an item should be on stock for customers. It aims to have enough stock on hand to make sales between replenishment cycles and calculates the minimal and maximum based on the number of factors, including current sales, sales trends, service level objectives. This method is best used for high turnover, high priority items. As with time supply, there are 2 variations on dynamic replenishment as well. First is dynamic issues algorithm, which works in a similar manner, but again, applies for warehouses. The other is dynamic seasonal, which takes into account the end of season targets similar to those we saw with the time supply seasonal algorithm. The last algorithm we have to look at is the store order algorithm, which allows stores to place orders based on their own needs. Recommended order quantities are based on store request and availability to deliver product given the lead times. A key variable in replenishment relates to how quantities are rounded. For a purchase order or transfer to be approved in replenishment, it must be rounded by either the store order multiple for transfer orders or the round level set for the item supplier origin country. The store order multiple can be defined as eaches, inner, or case. The round level for POs can be case, layer, pallet, case layer, layer pallet, and case layer pallet. For example, if case is chosen, it will round the order quantity either up or down to ensure that no incomplete cases are ordered. For the multi-level rounding options such as case layer, the item quantity is rounded first at the highest level, then moves to the lower level to determine if an order will be rounded up or down. The rounded thresholds defined at item supplier country of origin or item supplier country of origin location are used. Thresholds are percentages that are defined for inner, case, layer, and pallet and influence whether the quantity will be rounded up or down. The example on this slide illustrates how this works for case level rounding, assuming a case of 10 is 10 each in example. As you can see, setting the rounding threshold to 0% will always round up and setting to 100% will always round down, but it can be set for many different values in between. Also note that if the rules call for rounding quantity down to 0, merchandising replenishment will always order at least one case. This is illustrated in the last row of the example. Scaling is an optional facility that can be used to automatically scale the order up or down based on defined constraints. For example, orders can be scaled up to meet supplier minimums or down to fill trucks. Scaling is used on both manual generated and replenishment purchase orders. For forecasted replenishment orders, each item is scaled using the days of supply calculated during the replenishment process. For non-forecasted replenishment, merchandising adds one case to each item during the scaling process until the scaling thresholds are met. Scaling constraints are defined as in a range with a minimal and maximal value of tolerance for each. Scaling can be done either the minimal or maximal level. Users also have the option of having orders scaled at the total order level or by each location on the order. Truck splitting is the ability to systemically generate multiple POs from an order. It is triggered when a truck constraints are violated for an order and results in a purchase order being created for each shipment. This allows retailers to optimize shipment costs by ordering full truckloads. Constraints for truck splitting are managed at the supplier inventory management levels, but can also be updated by a PO-to-PO basis. This includes the truck splitting method, which can either be sequenced by an item number or balanced across the assortment, which attempts to place some of each item into a truck. Constraint type, which can be set to mass, volume, case, etc., UOM, which defines the unit of measurement for the type, and the value, which indicates the size of the constraint. Up to 2 truck constraints can be defined. Also, maximal scaling constraints can be defaulted to the truck constraints. Finally, note that when the PO constraints are enabled, only one location can be added to a PO. Due order processing allows retailers more efficient ordering as items are not ordered until they are due. A due order means if stock isn't ordered today, the service level of the item cannot be met. An item is considered due if the accepted stock out level of the item is less than the estimated stock level for the item. Due order processing parameters also set at the supplier inventory management level. Users also have the option of having orders evaluated at the total order level or by each item on the order. If using the item level processing, an order is considered due when one item on the order is due. When using the total order level processing, the stock out and expected stock levels for all items are summed to determine if the order is due. Users can choose to evaluate an order based on cost, retail, or units. Investment buy is the process of purchasing inventory in excess for recommended order quantity in order to take advantage of the best available cost. For example, if a supplier cost increase was pending or a deal was ending, more inventory may be purchased now to take advantage of the lower cost, if the lower cost of holding the inventory during this period is offset by the cost savings. In order to leverage investment buy functionality, a retailer must use a forecasting system such as RDF. All items are eligible for replenishment are also available for investment buy. Similar to replenishment, investment buy orders can be created with the order control options of manual, buyer worksheet, semi-automatic, and automatic with manual. Investment buys generates recommended order quantities to a table in the merchandising system. If buyer worksheet is chosen as the output for investment buy, then recommended order quantities are written to the buyer worksheet, just as they are with replenishment. With semi-automatic, the result depends on the status of the replenishment for any particular item location. If a replenishment purchase order and worksheet status exists for the same item location, the recommended order quantity is added to the purchase order. If, however, a replenishment PO does not exist, investment buy generates a new purchase order in the worksheet status. Automatic works similar to semi-automatic, except that orders are created in approved status. This concludes our session on merchandising, replenishment overview.